Okay, we are going to start the P3 vectors, and this is very important for us to recall the terms, the things that we learned in our O-level vectors. And we're going to basically build the P3 vectors onto your concept of vectors done in O levels. Okay, so out of the O levels vectors, there are some terms that I want you people to recall. Now, the first thing, the first most important thing is the position vector. The position vector. After this, I'll be discussing the direction vector. Then we shall discuss the unit vector. Okay, and in between, I will be needing your skills onto this addition of vectors where you were writing this AB as OB minus OA, okay? And your ability to find the magnitude of a vector. And then knowing that how two vectors are, parallel to each other, okay? How are two given vectors parallel to each other, okay? So we start from this position vector. Does anyone remember what do we mean by the position vector? Mhm. Yes, I'm waiting. Position vector. Does anyone remember the position vector thing? Hmm? Yes. Bolo yaar, position vector. Do you remember the position vector? Bolo, I'm just waiting for you people. अरे यार क्या हो गया नाराज हो गए सुबह सुबह अभी I was telling to the other class that I'm just like your mom, okay? So अम्मी से why are you so shy with your mom, okay? I'm your mathematical mom. So tell me if you can recall that position vector. Anyone? Yes, come on.
Sir, origin से जो
सही
vector.
Yes. Yeah, I'm just drawing it. You can take a hint from here. Like this is. Now suppose here is a point A, which is like, this is 3 here, and this is 4 here, and this is 3, 4. We know that the coordinates of a point tell us about the position of a point on a Cartesian plane. Yes or no? Yes? Yes? Yes or no? पता है ना फिर जब मामा डांटती हैं तो फिर कैसे डांटती हैं अब मैं भी बच्चों को मामा की तरह डांटा करना है मैंने तुम लोगों को so position of a point on the Cartesian plane is determined through its coordinates. So like we have 3, 4, so this point is 3, 4. Do you remember we writing this point, the column vector for OA, that is going to be 3, 4. Yes? This is 3, 4. Come on. बच्चों याद है कि नहीं? OA is 3, 4.
जी sir.
Yes. So this is called the position vector of A. If we are determining the point A from the origin, we just say that the position vector of A is 3, 4. If I tell you that the position vector of a point P is 5 minus 12, can someone tell me that what are the coordinates of the point P? If OP
5 and minus 12.
5 comma minus 12. So since the coordinates tell us the position of a point from the origin, similarly position vector is doing the same. There is only the difference of the way we are writing them. this position vector is written as a column vector, as a matrix, okay? And we write this point P like in the coordinates form. So there's a special way of writing the coordinates using these brackets and then writing first of all the X coordinate and then we write the Y coordinate, okay? Now, suppose we have a point here, which is, this is 1, 2, 3, this is 4, 1, 2, 3. Oh, sorry, this is 4. And let me take this 5 here. And this is 5. And I have it, let's say here, 5, 1. Okay. And this is 5 and this is 1 here. And this is my point B. So the point B is 5, 1. So what is the position vector of this B? Should I write it as 5, 1? So this B is as the coordinates 5. By the way, I'm just making you recall your O-level vectors. Okay, we haven't started the A-level vectors. Okay, so try to recall your knowledge about the O-level vectors. Okay, so yes. Now this is your OB. Now suppose if I want to find AB, can I say that this vector AB is AO plus OB? Now this AO can be written as minus OA, but so you have to object, you have to ask if you think yaar ye pata nahi sir kya likh rahe hain. Okay, because if you understand the basics of a chapter, you can easily handle the difficult questions. And if you're not even able to understand the very basic things, then I'm sorry, you will not be able to grasp the whole concept. Okay. Now this AB, you were told in your O levels that AB is written as OB minus OA. Do you remember this? AB is OB minus OA.
Yes,
Bolo.
sir.
Yes, sir.
Now, this will be used a lot over here. We will be just writing that, okay, I need PQ. So PQ is going to be OQ minus OP. I need XY. I have the point X. I have the point Y. So this will be OY minus OX. I need the vector CD. I have the point C. I have the point D. So this will be OD minus OC. Okay? You just remember this. Now, these position vectors, they were used to find the unknown coordinates of any points. ठीक है ना? अच्छा, position vector तो हमारे पास आ गया. So the next thing is the direction vector. Okay, how do you know that if how can you determine if two lines are parallel or not? Yes. How do you
Sir,
determine?
if the direction vectors are same.
I'm saying lines. I'm not saying the vectors. How do you determine if lines are parallel?
The gradients are same.
Exactly, beta.
Gradient.
If two lines are parallel, if their gradients are same, and when we have to deal with the vectors, you are absolutely right. Like you see that there is a vector like this. This is a vector OA, and this is 3, 4. And there is a vector like this. This is a vector CD, which is 6, 8. Okay. So now these two vectors are parallel. I'll not be using the term of the gradient over here. So two vectors are parallel if they have the same direction vectors. Now this vector is 3, 4 and the other vector is 6, 8. Why am I saying that they have the same direction vectors?
So because if we simplify 6, 8 or like take 2 common, we are left with 3 and 4.
Exactly. So from here, you see that a direction vector can be simplified. Like for example, if finding the gradient of something and you did that y2 minus y1 over x2 minus x1, and suppose you got 10 over 12. So you can write it as 5 over 6. So this is the gradient. Both are the gradients, but this is in the simplest form, okay? So basically, when we say that we're going to simplify this direction vector, we're actually saying that we're going to simplify the direction ratios. Okay. When we say that two lines are parallel, if their gradients are same, then we say that two vectors are going to be parallel if they have the same direction ratios, the same direction ratios. Like you see, this is 3:4. Okay, fine. The next is 6:8. You simplify this. This is also 3:4. Okay. Now someone is asking something in the chat. Okay, Iman Sohail. Okay. Acha. So this is 3:4. So this is 3:4 over. So they have the same direction ratios. So therefore, they have the same direction vectors. Okay. Somewhere you find there is a vector which is 5 minus 2. And then you have 50 minus 20, or maybe minus 10, 4. So all these three vectors, they are having the same direction vector. When we say they are having the same direction vector, we are indirectly saying that they are parallel to each other and they have the same direction ratios. Okay, you must note it down. Please note it down that saying that the vectors have the same direction vectors with the same DVs are actually parallel vectors because their direction ratios are same. Their direction ratios are same. Okay. Uh, so we have so far discussed the concept of position vector. This is related to the position of a point. Okay, position of a point. If you say OP, so that is clear, the position of the point P is relative to the origin. When we say AB, so that is like if there is a vector AB which is 2, 5. So if you have the point A over here, so you will go like 1, 2, 1, 2, 3, 4, 5. So this is, sorry, 1, 2, 3, 4, 5. Here it is the B, okay? So AB vector actually tells us the position of the point B relative to A. If you have the point A, you have the position vector AB, you can reach the point B. You know that this is going to be the direction in which you have your AB, okay? The next thing we have just talked about, that is the direction vector. It is related with the direction only, okay? And this is also related to the direction ratios, okay? Now, please see that if you have a vector AB, which is, let's say vector AB is 10, 15, okay? Now, we cannot simplify a position vector. What will happen if I start simplifying this? Yes, come on, tell me. What will happen if I simplify this 10, 15? Suppose there is a block over here, okay? And we are applying a force 10, 15 onto it like this. It is like this, this over here. So there's a force being applied here. This is the force AB, okay? So if you say, oh, okay, I can simplify it. Let me just keep it 2, 3, okay? What will happen? You keep it up to here. This is 2, 3. Yes? बताओ यार, कोई तो बताओ. What happens to the vector if you write it from 10, 15 to 2, 3? What will happen?
Sir, vector का magnitude कम हो जाएगा.
Magnitude will be, जीते रहो बेटा, the magnitude will be decreased like you see 5 times. Okay, so we cannot simplify the direction vector. Now suppose someone is asking you that, okay, I want to go to Islamabad. Okay, this is Lahore and here it is Islamabad. Okay, and suppose this is there is a position vector is let's say 1000 and this is 200. Okay, so if instead he's asking you that, yeah, what is the direction of Islamabad from Lahore? Then you can say, okay, that is going to be 5, 1. Okay, 5 steps this, 1 step this. So this is the direction vector. But if you simplify while telling the position vector, so you are actually decreasing the distance between Lahore and Islamabad. Okay, so we can simplify our direction vector to determine the direction ratios. So simplification is allowed. If you're noting it down, you can remember this. If you're just listening to me, then I'm sorry, you will never be able to remember this, okay? So our direction vector can be simplified because we are only interested in the direction. Yes, if you want to know that in which direction this force is being applied, you can say that the force is being applied in the ratio, in the direction 2, 3. But how much force is being applied? That is 10, 15. Okay, this 10, 15 is telling you the direction and the magnitude as well. Okay, so position vector, we cannot simplify this. This tells us the position of a point from another point. Okay, this contains both the direction and the magnitude. Okay, when we are talking about the direction vector, we are not concerned about the magnitude. We are totally interested in the direction of that particular vector. Okay, got it, bacho? The next thing is the unit vector. Now, the people who have done their add maths, they have studied this in their additional mathematics, and the O-level maths, they might not be knowing about the unit vector. Okay, now, there is a very small minor difference between the direction vector and the unit vector. Now, the direction vector is meant to tell us the direction of a vector in its simplest way, okay? But this unit vector is doing the same, but if you focus on this term unit, so a unit vector tells us, you can note it down, a unit vector tells us a particular direction with a magnitude 1, with a magnitude 1. With a magnitude 1, okay? Now suppose you have a vector AB, which is 3, 4, okay? Someone asks you that, okay, yeah, what is the unit vector in the direction of this AB? So this is already in the simplest form, okay? But we need the unit vector in the direction of AB. Now listen, before I tell you how to find this unit vector, tell me if you have AB, which is 3, 4. I believe you know that its magnitude is 5. Okay? Remember, this is 3 square plus 4 square. So this is going to be 5. Okay? This is going to be 5 here. Okay. So what if I have a vector CD, which is 6, 8? Do you see any relationship between A, B, and CD? Yes? Is there any relationship between A, B, and CD? Come on. Yeah, Sona to nahi aapka.
direction vector.
Yeah?
They have the same direction vector.
They have the same direction vectors. Very good. Anything else?
And
Yes? What someone is talking about the magnitudes, yes?
they're parallel.
Yes, they are parallel because the direction vectors are same. I just wanted you guys to note that this CD is basically twice the vector AB. Yes or no? CD is twice the vector AB. Yes?
Yes, sir.
और यार CD is twice the vector AB. अब ये वाली बात के लिए भी सोचोगे तुम लोग, हाँ? अच्छा. Now, if I ask you that what is the magnitude of CD, so that would be 6 square plus 8 square, and you will get 10. Okay? So if CD was twice the vector AB, then the magnitude of CD is also twice the magnitude of AB. Yes or no?
Yes.
Yes. Okay. Now, if the magnitude of this vector AB is 3, 4. Now tell me what will be the magnitude of a vector 3 over 5 and 4 over 5. This vector has a magnitude 5. If I divide the vector with 5, so what will be the magnitude of this vector? Yes.
1.
1, G0, that will be 1. Even if you do that working over here, this is 9 over 25 plus 16 over 25. You see that this is 25 over 25. So that is equal to 1. So this 3 over 5, 4 over 5 is a unit vector in the direction of AB. This is a unit vector in the direction of AB. Now, one of the uses of these unit vectors is, now suppose someone says, I need a vector with a magnitude 100 in the direction of AB, in the direction of AB. So you first of all write down the unit vector and then you multiply it with 100. So 100 times 3 over 5, 4 over 5, because you know that this has a magnitude 1. If you multiply it by 100, the resulting vector will have a magnitude 100. Yes or no? Yes or no?
Sir, can you explain this again? Like,
Look at this. If
yeah.
this vector had a magnitude 5, you multiply it by 2, the resulting matrix will have a magnitude 10. Is that so?
Yes, sir.
Yes? Okay. Now, this vector over here has a magnitude. What is the magnitude? यार इतनी देर क्या है इसका magnitude यार?
1
1. So if you multiply this by 100, the resulting matrix will have a magnitude
of 100.
of 100. That is why we're doing this. Now suppose you have a matrix, you have a vector 5 minus 12, okay? You know that its magnitude is going to be 13. So 5 over 13 and minus 12 over 13 is a unit vector in the direction of this vector. Yes or no? Yes?
Yes.
Yes, okay. Now, if I say, if the question is that, give me a vector which is in the direction of this vector, but has a magnitude of 50. So wouldn't that be 50 times this? Yes, 50 times this. This is a vector which is in the direction of this vector and has a magnitude of 50. Bolo yaar.
Yes.
है ना देखिए ये बिल्कुल ऐसे ही है if you remember that unitary method that you did in your very junior classes, that suppose if someone says that 5 lollies, they cost, let's say, 100 rupees. So what is the cost for 12 lollies? Yes, so you will find the price of one lolly, है ना? You know that one lolly is going to be 4 rupees 20. And then 12 times 20 will give you the price of 12 lollies. That is going to be 240 rupees. That is the unitary method that you have done. We're just repeating that unitary method over here, that you find a vector with a magnitude 1. And then you multiply it with whatever magnitude you want to have. Okay. So in short, in um, in our simplest words, now can you tell me, are you familiar with the position vector?
Yes, sir.
You must be familiar with the unit vector. You must, like before
Yes,
the
sir.
unit vector, I should write the direction vector and then the unit vector and then the magnitude, okay? And then the parallel vectors, okay? If you're all familiar with these position vector is to determine the position,
Position of the vector.
and we can simplify it, okay? if you see a very juicy position vector, suppose you have a vector 100, and this is like, you're getting tempted to simplify this, but you will not simplify because this is a position vector. Okay, we can't do anything with this. Suppose it has both the minuses with this, even then you can cancel out these minuses. Okay, direction vector is purely aimed to give us the direction. Okay, so we can simplify it. Okay, we can simplify. Suppose you have 12, 15. So you can write it as 3 4s are, 3 5s are. Okay. Unit vector is again related to with the direction, but direction in a way that with magnitude 1. Okay. And parallel vectors, they have the same direction ratios. Okay. So this was a brief recap of what you have done. And one more thing that is very important over here, that is AB is going to be OB minus OA. CD is going to be OD minus OC. Okay. So you remember all these things. We come back into the next session and we shall start studying the A-level vectors. Okay. Now please come back for the second session.